In this video, I'd like to continue our discussion of dividing polynomials by x, but this time we will have remainders. So with these problems, we will have some polynomial up top and some down below, and in all of these, we'll just have a first degree polynomial, x, in the denominator. But with these problems, we'll end up with some kind of remainder term. So our answer should be some polynomial p of x plus some other term, some fractional term, k over x, where k is an integer. And remember, an integer is just a whole number, including negatives and zeros. So let's rewrite this. We have 6x squared minus 4x minus 3, second degree polynomial in our numerator. And we're dividing by this first degree polynomial in the denominator. Now remember that x is going to divide into all three of these terms. So we can rewrite this as 6x squared divided by x, and then minus 4x divided by x, and minus 3 divided by x. And when we do this, we can now simplify. So we have 6x squared divided by x. So there are two x's up top, one down below, and so one of them will cancel out, and you get 6x. Since, remember, x squared over x is really just x times x divided by x. And like I mentioned, one of those x's will cancel out since x divided by x, or anything divided by itself, is always equal to 1. So this becomes 6x. This x divided by x, those will cancel. We get minus 4. And then here we have this minus 3 over x. And since we don't know what x is, we're not going to be able to simplify this. So this term right here, this is what we're calling our remainder. We're not able to simplify that further, so we can just leave it as that fraction. So when we put our answer into the box, this right here is the polynomial, this p of x, and this right here is our plus k over x, where k in this case is negative 3. So we'd put 6x minus 4 minus 3x in as our answer right here. So let's keep going. These are all going to be pretty similar. So this one, we're going to divide each term by x. So I'll just rewrite it as 3x squared divided by x, and then the minus 10 is divided by x. And you can see this minus 10 divided by x, that's going to be our remainder since we don't know what x is, and so we're not going to be able to simplify that. But this one, the 3x squared divided by x, well, we know when we have two x's up top and one down below, that one of them will cancel out, and so we're just left with 3x. And we have this minus 10 over x, which we can't simplify, and so this will be our answer. We can put this into the box. And you'll see some of these are fairly straightforward, fairly quick, but this will help set up for much more complicated problems, where we're not just dividing by x, where we could be dividing by anything, maybe even x plus 2. So this is what we're building up to, and these can be more complicated, and we'll talk about that in later videos. So let's do another one. So we have 3x cubed and minus x minus 2, and they're all divided by x, so I'll just write them as divided by x. So then we have minus x divided by x and minus 2 divided by x. Now, the 3x cubed divided by x, you have 3 x's up top, and one of them will cancel out. So now we have 2 x's, or 3x squared. And then x divided by x, something divided by itself, is just 1. In this case, it's negative 1 because we're subtracting. And then this minus 2 over x, we're again not going to be able to simplify that just because we don't know what x is, and we won't be able to divide those numbers. So 3x squared minus 1 minus 2 over x goes into our box, where the 3x squared minus 1 is our polynomial, and this minus 2 over x is going to be our remainder term, where in this case k is minus 2. Let's do one more of these, and I'll just rewrite this with our division by x into each term. So x goes into the 5x squared, the plus x, and the plus 7. So 5x squared divided by x, then we have x divided by x, and 7 divided by x. And x squared divided by x, you'd have 1 left over, so that's just 5x. X divided by x would be positive 1, And the plus 7 over x, we can't simplify, so that's our remainder term. That's this k over x. So this would be our final answer for this problem.